emails about this if you haven't completed it yet. But I just wanted to make a quick plug. The survey closes tomorrow. So UMMS has contracted an outside vendor to audit operations. They've done in-depth interviews with many people. They've been out on the units over the past couple of weeks and will continue to do so. And then the final part is a score survey. So we want feedback on how the staff feels that the organization is doing on patient safety, quality of care, communication, workplace violence, security, all that good stuff. And then this outside company is going to give us a report back and make recommendations of a roadmap of how we improve all of those things. So it only takes about 10 minutes. Please take the time to do it today or tomorrow. You can scan this code here, or you have the link in your email as well. All right, if you have any questions, you can shoot me an email or I'll stay on for a few minutes in the chat. But thank you so much for the time. Please do the survey.
All right, awesome.
Thanks, Jen. Wait, and before Dr. Atlas, I just want to make sure that Dr. Adachi can get his slides up.
Okay.
So we're gonna do that real fast.
Okay, go ahead.
Dr. Adachi, whenever you're ready to try to share your screen.
Okay.
I bet he's an expert at this.
I think he is.
We can have a discussion about that.
We already tested it earlier and he was expert at it. Yes.
And there it is.
Yep, we see it, Dr. Adachi. Yes, you advance.
Okay.
It looks good. So Dr.
right.
Atlas, the floor is yours.
Well, good morning, everyone. I actually really have a distinct honor of introducing our speaker this morning, Dr. Ellie Adachi. I have known Dr. Adachi personally since the late 80s and have watched his career, and I'm going to go through some of this, and I just want you to know that I won't be able to do it full justice to everything that Dr. Adachi has accomplished in his career. He started off his career graduating from Tel Aviv University School of Medicine. I'm not going to give any most dates, just so I I don't even want to give my dates when I was in residency and all that. He then came to the United States and did his residency at Tufts University, a fellowship in reproductive endocrinology at the Johns Hopkins Hospital. And it's important to know that Georgette Jones and Howard Jones were his mentors there. He also did part of his fellowship at the University of San Diego under the auspices of S.C. Yen, who is a very big person within the reproductive faculty. He then came to the University of Maryland. This is where he was part of the residency and fellowship and division director of reproductive endocrinology when Maryland had it from 1981 to 96. He then became the chair at the University of Utah from 1996 to 2004. And he has been at Brown University since 2004. And he was the 5th dean of the School of Medicine at Brown. He decided while he was a dean to get a healthcare management at the Harvard TCN School of Public Health, just as an aside. He has been president of numerous societies, including the Society of Reproductive Endocrinologists, the Society of Gynecologic Investigation, the American Gynecologic and Obstetrical Society. He's been a board examiner and head of the director of REI for the American Board of OBGYN. He has mentored more than 50 postdoctoral trainees and fellows. He has authored or co-authored more than 400 peer-reviewed publications, 120 book chapters in areas of reproduction, the law, ethics, and human rights. He had continuous funding from the NIH from 1985 to 2005. He has been editor-in-chief of Seminars in Reproduction and associate editors of a number of different journals as well. Presently, Dr. Adachi is the chair of the Medical Executive Committee and the Medical Advisory Council of the Jones Foundation for Reproductive Medicine. He's a member of the Advisory Council of the Hastings Center and a member of the Board of Governors at Tel Aviv University. He also is a Franklin Fellow and Senior Advisor on Global Women's Health to the Secretary of State Office of Global Women's Health and his first term was under the Obama administration. I could keep going. Currently, Dr. Adachi is a tenured professor of medical science at Brown University. He's a member of the Brown Center for Prisoner Health and Human Rights while maintaining multiple educational responsibilities, inclusive of the directorship of the Healthcare in America course, a highly subscribed medical school elective, and directorship of the Healthcare Policy Concentration. I also wanted you all to know that he was an elected member also of the National Academy of Medicine, of the National Academy of Sciences. You just don't recognize the power of the individual who is about to speak to us on a very interesting title. I really am very interested to hear Dr. Adachi's talk on the eggs and sperm from a buccal smear. So with that introduction, Dr. Adachi, so welcoming to have you back at the University of Maryland, even if it's just virtually.
Thank you, Rob. I very much appreciate it. And yes, I continue to cherish my 15 years at the University of Maryland at the time. It was my first faculty appointment, and it was a very rewarding all-around experience, which perhaps explains in part why I'm always happy to come back and deliver grand rounds, for example. And prior to the pandemic, of course, this would have been an in-person delivery, which it was for many years. And I hope that at some point, when it's all over, which might take a little bit, perhaps we can renew the in-person contact. I wish I could walk down those steps at the Shock and Trauma Auditorium towards the podium and see you all as I speak. Right now, all I see is a few images on my Zoom screen. The subject matter of today, as Rob already alluded to, is at first sight somewhat elusive, but you'll be surprised to learn that this is not all that far away. And in my opinion, will have profound influence on human reproduction in all its facets. I will just stray for one additional minute when I say that we live in extraordinary times in terms of the science. This is just one example of what's happening out there. There are absolutely mind-boggling developments in our ability to grow synthetic life effectively, embryos for that matter, albeit not in human at this time, but still clearly moving ahead. A lot of issues in science are now giving way to the power of investigation, and reproduction is no exception. Perhaps another time we can talk about those other developments, which are also completely shake the foundations of what I think most of us have been taught about human reproduction, at least as we knew it. The notion of creating mature cell lineages from stem cells is not unique to the reproductive arena. For example, there is an interest in developing amacrine neurons that could be used to treat certain retinal diseases. There are efforts to produce dopaminergic neurons that could potentially be placed in the striatum in the context of Parkinson's disease. There are efforts to create, as I mentioned already, trophoblast precursors. In fact, it's no longer efforts, it's a reality. And what I refer to as synthetic life is in effect a byproduct of this development. There are efforts to develop motor neurons with an eye towards perhaps treating paralysis that is attributable, for example, to spinal injury. And finally, and of course, today's topic, there are efforts underway to develop gametes, which is what we will be discussing today. To give you some sense of where this stands on the hierarchy of priorities, I'm showing here an infographic produced by the Nuffield Council on Bioethics, which is the premier bioethics organization of the United Kingdom. Under human reproduction, the very first item that they are proposing to study is in vitro derived gametes, to be followed by time limits on maintaining embryos in culture, womb replacements, so-called ectogenesis or uterine transplantation, preconception screening, whole genome sequencing of embryos and fetuses, genome editing of gametes and embryos, all frontiers that are currently being looked at, and egg freezing. But in vitro gametogenesis, as you noted, was at the very top of the list, partly because I imagine the Nuffield Council made a certain assumption that as these developments materialize, in vitro gametogenesis is likely to be in the lead. There is no question that this is a disruptive technology, although it's still somewhat of an open question, as we will discuss whether it's achievable in the human. And again, although debatable, there are significant suggestions that the timeline is short, and I'll give you some additional indications for some of that later. We will do well as we speak about these futuristic topics to recall Aldous Huxley's remarkable contribution back in 1932, the so-called Brave New World, which many of you may have read either as adolescents or perhaps as adults, which remains an inspiring text to this day. In this book, Mr. Huxley makes several predictions. He predicted that eggs will be produced, as he saw it, via ex vivo ovarian cultures. It's not quite in vitro gametogenesis, but it's clearly a different way than nature intended. He envisioned the production of embryos via in vitro fertilization, and he predicted that newborns will be born via ex vivo ectogenesis, that is to say, in an artificial womb that will carry the conceptus for 9 months, and thereby, in a sense, no longer be carried as we are used to in a mother's womb. He was, of course, spot on in vitro fertilization, because in 1978, as you all know, this became a reality. It was a Nobel Prize-winning discovery of Drs. Edwards and Steptoe in the United Kingdom, and the rest is history. We have this going in the United States now for 40 years. It's a matter of, it's now standard care. It's nothing that we need to spend a whole lot of time about, but it's useful to recall that Mr. Huxley foresaw this coming and predicted it in his book. The rest of the time we will devote to in vitro gametogenesis. But before we do, I want to quote one more quote from Mr. Huxley's book from chapter 1, wherein the director of hatcheries and conditioning, as it's referred to in the book, says, 1 egg, 1 embryo, 1 adult, normality. Making 96 human beings grow where only 1 grew before, progress. As you will see, quantity is not an issue with in vitro gametogenesis. We can produce unlimited amounts of in vitro derived gametes, which on the one hand is of course a plus, but on the other hand produces or raises all kinds of issues of ethics, of security, of legality, some of which I will touch upon. We probably cannot and will not be able to cover it all, but I want to give you a sense of not only the immensity of the breakthrough, but also of the complexities that it brings about. For the longest of time, the notion of somehow creating germ cells from somatic cells was considered a no-starter. And that was because of the soma germline barrier hypothesis, which was formulated by August Weismann, who was professor of zoology at the University of Freiburg, who articulated his theory in a book titled The Germplasm, A Theory of Heredity. Based on that hypothesis, the germline, of course, ultimately gives rise to the soma, and for that reason can be deemed immortal. On the other hand, the soma never gives rise, of course, to the germline until recently, and therefore must be deemed mortal. All of that is really what has been, shall we say, I don't want to say debunked, but has been now superseded by new developments which allow us to take a somatic cell and convert it into a gamete. What's involved is taking a fully differentiated somatic cell, let's say a skin cell, convert it into what is known as a pluripotent stem cells, a cell that has the ability to develop essentially in any direction we guide it to. And if we know the book of instructions, if you will, that will take a pluripotent stem cells to a gamete, if we know the signaling system and the sequence thereof, in principle, we could take a pluripotent stem cell towards a gametogenic fate. Now, this became possible because of really two technologies. The first was known as somatic cell nuclear transfer, or SCNT for short, which was developed in 1958 by John Garden, a Cambridge University-based scientist who published a seminal paper in Nature titled Sexually Mature Individuals of Xenopus laevis from the Transplantation of Single Somatic Nuclei. In other words, using the frog as a model, Dr. Garden took a somatic nucleus, essentially, transferred it into an enucleated oocyte, created what amounted to a zygote, or which developed into a blastocyst, and from that he derived what we now call embryonic stem cells, which is one variety of pluripotent stem cells. In 2006, a new technology was developed, generally referred to as induction, by Shinya Yamanaka of Kyoto University in Japan, who published a key paper in Cell titled Induction of Pluripotent Stem Cells from Mouse Embryonic and Adult Fibroblast Cultures by Defined Cultures. The approach he took was to begin, of course, with the somatic cell and transfect it with select transcription factors, a combination that he studied and defined, and in so doing, convert the somatic cell into what is known as an induced pluripotent stem cells. So that gives us yet another version of a pluripotent stem cells, which in principle could be guided into any direction. Both individuals were rewarded by the 2012 Nobel Prize in Physiology and Medicine. So in vitro gametogenesis, building on this body of background, involves starting the process with a somatic cell and converting it into either an embryonic or induced pluripotent stem cell, and then armed presumably with the appropriate instruction book, convert that pluripotent stem cell into a gamete. So the prerequisites for this to happen is to know what could be described as the germ cell specification pathway. You would need to know the cues that need to be provided to the cell. You would need to know the sequence in which those cues are applied to the cell and the timing thereof. And you will also have to consider what is known as the niche, which is the surrounding somatic cells. Because when you reflect on the oocytes or the sperm, you realize that they are surrounded by somatic cells. The oocyte is surrounded by the granulosa cell and the theca cells, and the sperm sequence is surrounded by the Sertoli cells. And so clearly some cues are also provided by these surrounding cells, which are sometimes referred to as the niche or the niche that surrounds the germ cell compartment. The beginning was very modest. In 2003, Dr. Schoeller, who is now at the Max Planck Institute for Molecular Biomedicine in Germany, but at the time was a postdoc at the University of Pennsylvania, published a paper in Science in 2003 titled The Derivation of Oocytes from Mouse Embryonic Stem Cells. A picture of such an oocyte is shown on the right lower hand corner of the slide. This, of course, is a very early effort. As you will see later, this has been improved upon substantially. That same year, a Japanese investigator, Toshiaki Noche, reported on the pages of the Proceedings of the National Academy of Science a paper that was titled Embryonic Stem Cells Can Form Germ Cells in Vitro. A year later, George Daly from Harvard Medical School, presently the dean of that medical school, reported on the pages of Nature the derivation of embryonic germ cells and male gametes from embryonic stem cells. And in the same year, René Rehopera, an investigator from the Bay Area, reported on the pages of Human Molecular Genetics a paper titled Spontaneous Differentiation of Germ Cells from Human Embryonic Stem Cells in Vitro. In the subsequent decade, several important papers saw press in Nature, Science, and Cell, further buttressing the feasibility of this effort, all of these particular papers dealing with the rodent. But a parallel series of equally important papers published in Nature, Cell, Embryo Journal, Cell Stem Cell, dealt with the germ cell specification pathway in the human. So as we look back at the state of the art in 2015, the germ cell specification pathway was shown to be quite broadly applicable and not necessarily conserved between the rodent and the human. And we've also found out that what works for perhaps the rodent may not work for the human and vice versa, which is to say that the genetic networks involved are quite distinct as well. Schematically, the state of the art in 2015 was that we knew, of course, how to produce embryonic stem cells, stem cells either embryonic or induced. This was the extragonadal component, you would say. And we knew how to convert them to so-called primordial germ cell-like cells. What we couldn't do at that point anyway, is to convert those primordial germ cell-like cells to mature, haploid, postmeiotic, mature gametes. In a word, we mastered the extragonadal component of the process, but we have yet to master the intragonadal component thereof. The final frontier was, of course, complete in vitro gametogenesis all the way, starting, say, with a skin cell and ending up with a mature oocyte or a mature sperm. Moving us forward along these lines was a key paper published in 2016 in Nature by Katsuhiko Hayashi from Kyushu University in Japan. The paper was titled Reconstitution in Vitro of the Entire Cycle of the Mouse Female Germline. And what Dr. Hayashi accomplished was truly remarkable. He started with embryonic stem cells or induced pluripotent stem cells, combined them with primordial germ cell-like cells, and then added some gonadal somatic cells to simulate an ovary. After a while, this combination gave rise to primary oocyte, eventually to an M2 oocyte, a depiction of which is shown on the left-hand side. Upon fertilization of those eggs, blastocysts were formed, transferred to corresponding mothers, and pups were born in due course. In a word, Professor Hayashi took the process from the very beginning to the very end. He started with stem cells and ended up with live pups. This is true for the rodent, and as we will see, we have yet to achieve a similar feat in the human. The efforts at the level of the human were led primarily by Professor Michinori Saito from Kyoto University in Japan, whose most advanced paper was published in Science in 2018, wherein he started the process with human primordial germ cell-like cells, which he combined with xenogeneic ovarian cells to give a somatic component. And he was able to take those primordial germ cell-like cells all the way to the oogonial stage. But he was not able to take it all the way to the M2 oocyte level, which would be a fertilizable gamete. In other words, the feat that was accomplished in the rodent has yet to be accomplished in the human. But it's also easy to see that we are close. We're not all that far from accomplishing what on the surface strikes one as a truly revolutionary undertaking. The scientific community has definitely taken note of these developments. Science, for example, Science magazine saw fit to publish an extensive review on mammalian in vitro gametogenesis in 2021. The same can be said for the New England Journal of Medicine, which saw fit to publish a paper titled Oocytes from Stem Cells in, this very year, earlier this year. all of which I think you can agree indicates that the scientific community can see this coming, even though we still have a few bridges to cross. Yet another body that is already recognizing the writing on the wall, if you will, is the National Academy of Medicine. And yours truly and many others are involved in organizing a workshop. It will probably be in 2023, that will be specifically dedicated to in vitro gametogenesis. It's also entirely possible that the National Academy of Medicine will dedicate a report to the subject. So that would be a published document written by a committee. That is not likely to take place before 2023-24. All of these things, by the way, cost money. And yours truly was heavily involved in the last 2 years in helping the Academy raise the necessary funds. So we have clearly missing links, and the missing links at this point in the human is the knowledge of the germ cell specification pathway, the generation of gonadosomatic cells or the simulation of their input, the so-called niche, and the ability to faithfully replicate meiosis, because we can't afford meiosis to somehow go awry or be ill accomplished in some fashion. The rules for, if you will, faithful replication of meiosis have been laid down by a critical paper in Cell in 2014 by Mary Ann Handel from the Jackson Laboratory and Associates. And the criteria which they called for is that the derived gametes are going to have to be shown to have the correct nuclear DNA content, the normal chromosome content and organization, and the appropriate synapses and recombination mechanisms. And so the road ahead, if you will, is laid out, and now we are essentially waiting for the final stages of this process to materialize. Usually, as you know, what happens is the New York Times breaks a story and we play catch up. In this case, the hope is that we can, in fact, anticipate the New York Times story and develop this issue and study it and appreciate its implications, which are multiple, and I'm about to get into, ahead of time, rather than play catch up. That's the whole idea behind the National Academy of Medicine workshop and commission, with an eye towards really laying down the ground rules for what could be, on the one hand, a remarkable breakthrough in reproduction, but on the other hand, not a trivial headache from the point of view of what could go wrong. So, before we go there, I think it's useful to reflect for a moment on the scientific and translational promise of this technology. This will provide us, if it materializes, with an inexhaustible supply of germ cells. It will allow for all kinds of in vitro studies, so-called functional non-mutant analysis, wherein you knock out one gene or another and ask, what does it do to the gamete and its functionality? And you could study for the first time in a meaningful way on a large scale germ cell somatic cell interactions. But there are clinical benefits as well. You could reverse germ cell failure in individuals who lack gametes for one reason or another, or who undergo premature failure. You could engage in so-called autologous gamete replacement, infeasible today. If we're dealing with premature ovarian failure, we have no cure but to resort to donor egg, for example, and resort, in all likelihood, to IVF. We can also gene edit gametes to correct in the case that gametes are carrying heritable abnormalities that we do not wish for them to be transferred. Let's say we know there is a genetic family issue and there is concern that that condition will be perpetuated. You could, in principle, edit it out if you had access to multiple gametes that were available in culture, which is what will happen, and could be edited with an eye towards normalization. Those of you who have followed the field of mitochondrial replacement therapy, which is a technology designed to allow women from families with mitochondrial disease give birth to healthy children. This could also play a role there because it would provide gametes, presumably normal gametes and normal nuclei that could be donated, if you will, to the women in question. Right now, another woman usually from a healthy family usually volunteers to provide an egg. But in this case, you could potentially have a large bank of donors and you would not have to impose on others. When it comes to IVF, this will be transformative. This will essentially eliminate the need in gonadotropin stimulation and in egg retrieval. A woman will provide a skin cell, presumably. That skin cell will be turned over into a gamete, and that will be fertilized with the husband's sperm. This will do away with gamete donation in all likelihood. It will effectively convert IVF to a laboratory procedure. We will still need to worry about endometrial preparation and transfer, but much of what is currently busy work in IVF will be no more. It might improve affordability and thus access, although all of us have been there before, and those promises, even though intriguing, often do not materialize. Before I go to regulation, I will also say that this has profound implications to the very future of the discipline of reproductive endocrinology, which currently heavily rests on the shoulders of IVF. What if IVF became a non-procedure? What would reproductive endocrinologists do in the future? That's a question I posed to the leadership of the field now on a number of occasions, most recently during a plenary presentation at the American Society for Reproductive Medicine. And I continue to encourage our leadership to think ahead of what this would mean to the subspecialty of reproductive endocrinology 10, 20, possibly 30 years from now. Because it's unlikely that we will revert to who we were prior to IVF. So who are we going to be, I think, is an important question that has yet to be dealt with. Needless to say, if this ever comes to pass, which we all suspect it will come under the jurisdiction of the FDA, which will have to approve these cells as credible. The branch of the FDA that deals with those kinds of issues is the Center for Biologics Evaluation and Research, or known as CBER for short. And doubtlessly, they will have to sign off on the credibility of the newly derived gametes. This, in their jargon, comes under HCTPs, or human cells, comma, tissues, comma, and products. So there's a long way ahead of us in the sense that the science has yet to be fully materialized, definitely in the human. And once that occurs, multiple requirements will have to be met to assure all of us that these quote unquote artificial gametes are truly comparable to the real thing in every possible way. There are also profound ethical considerations here, which I will only deal with briefly. On the one hand, this clearly meets the principle of Hippocratic beneficence, because it will help a significant number of individuals who, for one reason or another, cannot reproduce due to germ cell failure. And this could, in principle, address their underlying pathology. And so there is clearly some good involved here that we would consider to be compatible with the mission of medicine. In some cases, as we already mentioned, this could be of consequence in the context of infertility relief. On the other hand, there is definitely an issue here of the commodification of reproduction. As you will see, once we get into the realm of artificially produced gametes, numbers are no longer an issue. And the availability of a limitless number of eggs raises the prospect of commodification, the implications of which we can all imagine, and rules will have to be put in place to ensure that this does not get out of hand and backfires. Which is to say, yet again, progress does not come without some challenges. And we recognize that this technology, breakthrough technology as it is, could easily fire back in a variety of ways too. This will also call into question the notions of parenthood, because you could imagine all kinds of combinations of artificial eggs and sperm that involve anything but conventional sexual intercourse. How all of that will play out, how are we going to deal with this ethically speaking and legally speaking, I'll get to that, is, I think, still an open question. And in all of this, there's always what I call the enhancement overhang, the notion that we can also enhance these eggs if the parents wish, for example, to have this or that trait added to the mix, or this or that disease prevented. In theory, those gametes could be edited with an eye towards enhancing them. Big question in general, definitely applicable here by the time this breakthrough comes about. So a whole potpourri of issues, as you can see, that will have to be dealt with, which is why I think it's so important to face up to this ahead of it becoming a reality, which most of us feel is inevitable. We talked earlier about the issue of quantity and commodification, and really what you need to envision in your mind are such 96 well contraptions, each of which may contain hundreds of gametes that were in vitro derived. Should we put limits on scale? Should we put limits on choice? What about the disposition of the embryos, which in the United States obviously is in general more complicated than it is in any other nation on earth. As I mentioned, several deliberative bodies at one point or another are likely to delve into this. I mentioned already the National Academy of Medicine. They are the most likely target here. There used to be, as you recall, a presidential commission for the study of bioethical issues. For reasons I'm not clear about, President Biden and President Trump before him did not renew the Presidential Commission for the Study of Bioethical Issues, for reasons I'm not clear about. And then there is the Hastings Centers, which is our national premier ethics center, which has the capacity to deal with this issue definitely on the ethical side, but could potentially take on other aspects of the issue as well. I already mentioned the legal implications. I will not delve very deeply into this. I'm obviously not a lawyer, but I often co-author papers with legal experts. And it's been pointed out to me on a number of occasions that this is going to be a major legal challenge that will have to be figured out ideally in advance. Here's, for example, one completely unthinkable scenario today. Imagine you're in a restaurant having a cup of coffee, and then you leave the cup of coffee on the table, and somebody proceeds to retrieve that cup of coffee, recover a few of your skin cells off the cup of coffee, converts those into gametes, and before you know it, your gametes are in the public domain. And before you know it, you may in fact be a parent. This is what we refer to as unwitting, non-consensual parenthood. An unthinkable process today, but not impossible when you start thinking about gametes that are readily available and producible from, let's say, a skin cell that all of us leave around all day long. And so if criminal interests of one kind or another were interested in creating this kind of trouble, this becomes feasible. And therefore, this is just one of multiple scenarios that could be imagined that will require, as much as possible, legal protection, although we know full well that legal protection is not everything, and that crime has not necessarily been eliminated simply by crafting laws and regulations. At some point, it would be helpful to engage the public as well, and that's a new facet that's been added to many of these breakthrough technologies. The idea of so-called participatory public engagement. This is very important, still not quite operating, I think, at the intensity level that it deserves. But it all goes back to a famous conference that took place in 1975, the so-called Asilomar Conference on Recombinant DNA, that took place in February of 1975, but which was scientists only, experts only, by invitation. The public was not invited. Decisions were made, but the public was not consulted. This is often brought up as the example of how not to do things, how not to proceed with breakthroughs in science. Recombinant DNA at the time was comparable to artificial gametes today. It was a breakthrough technology. It opened up all kinds of possibilities that we couldn't even fully foresee, but the public was not consulted. Senator Andrew Kennedy, for example, addressed this issue afterwards on May the 9th, 1975 at the Harvard School of Public Health by saying, when science develops techniques that fundamentally change society, society has the right to determine how the technique is to be used, whether it should be developed in the first place, and if so, under what constraints. A National Academy report in 1995 was titled Society's Choices. In other words, the subtitle was Social and Ethical Decision-Making in Biomedicine, which delved into the same issue. The lead author of that report was Harvey Feinberg, later to become the president of the National Academy of Medicine. In 2008, another report of the National Academy of Medicine titled Public Participation in Environmental Assessment and Decision-Making, SOPRESS. One quote from that report reads, "Public participation is intrinsic to democratic governance." I can tell you that in Europe, this is a standard fare. Budgets are determined with public input. Any issue of consequence involves public input. We have a long way to go in the United States to even approximate that level of activity. Sheila Jasanoff, the faculty at Harvard, in her book, Science and Public Reason in 2012, stated that the issue is no longer whether the public should have a say in technical decisions, but how. We could learn, as I said, from the Europeans. Here's an example of how the Brits did it when it came to genetic technologies. They conducted a public dialogue and summarized the opinions. This was conducted by the Royal Society, and then they published a report that essentially gave Parliament a good sense of where the public stood on this matter. The Nuffield Council, which I mentioned earlier, in July of 2018, stated, establishment of a separate body or commission, independent of government, which would produce an understanding of public interests through promotion of public debate, would be useful. We do not have a standing body, but as I mentioned, it's likely the National Academy of Medicine or some such body that will assume this responsibility. I'll conclude where we started with the Nuffield Council on Bioethics, which, as you recall, placed in vitro derived gametes at the top of its list. Now that we've gone through the sequence of challenges and mines and all kinds of issues which we could all end up stumbling on, I think it's perhaps more clear why the Nuffield Council on Bioethics thought that this issue deserves the most immediate attention, because it's likely to happen. It's likely to happen, to use a term, in our lifetime, which is an interesting term to discuss, but implies that it will happen within a reasonable period of time, and therefore deserves careful deliberation now, rather than after the story is broken by the New York Times. So stay tuned. this is an evolving story that I thought would be useful to share with you so that you're not stunned when you read the New York Times. By then you could have said, well, we already heard Dr. Adachi give us at least a primer on what might be coming down the line. We're not falling off our chair as we might otherwise. We, in fact, have some sense of what all this means. And most importantly, we are highly sensitized to the various complexities that this introduces, which must be approached responsibly on a national level, which is really what the current planned workshop and planned commission, likely, of the National Academy of Medicine are seeking to accomplish. So with that, and seemingly on time, I'm going to end. And thank you yet again for the opportunity to visit with the University of Maryland, which in many ways I consider my alma mater. I continue to be committed to the school and to the department, and I sincerely hope that going forward, all variables permitting, I can visit in person, going back to the walking down the steps of the Shock and Trauma Auditorium to the podium and doing all of this in person rather than via Zoom. So thank you very much for the privilege, and I'm obviously happy to answer any questions should there be any.
Well, thank you so much, Dr. Adachi. That was an amazing, eye-opening discussion. I have to admit that I have very little knowledge on, and certainly our colleagues, especially our residents who are interested in reproductive endocrinology, this is certainly food for thought for them entering a field where it may be very different, as you said, maybe 30 years from now.
Yeah.
Are there questions from the audience? I'll just start. I mean, I hate to bring up political, but where the United States is currently, Dr. Adachi, with the rights of the, where we are with abortion and, where do you think that's going to take us in regard to the development of this kind of technology? And what we currently have with IVF, with all those frozen embryos? I mean, I can just imagine the angst of the reproductive endocrinology community, even as it sits today.
No, thank you, Rob, for raising that. That is clearly on the mind of many. For whatever that's worth, we wrote a paper in JAMA a month or two ago where we shared some thoughts on what the Dobbs decision could mean to IVF in the United States. But more broadly, I will share with you a perspective I've articulated before. IVF has been around now for 40 years and in the United States. And even though we all were concerned along the lines of your question from the get-go, and in fact, for those of you who are old enough to remember, before IVF even came to the United States, Congress held hearings in which individuals from the discipline testified. Dr. Mastriani from the University of Pennsylvania, Dr. Wallach, who at one point was at Johns Hopkins, of course, Richard Marsh from California, and others have testified before Congress, which was concerned about the implications of IVF. But since 1981, so 40 years since the establishment of IVF in the United States, we have had very little, if any, intervention in the business of IVF by the federal government or the Congress. And while you cannot provide a clear-cut explanation, one likely reason for that is that virtually every member of Congress or a relative thereof will at some point have encountered infertility, very possibly will have dealt with IVF, and may well have embraced a baby who was born as a result of that technology. And even though pro-life sentiments may run high in some circles of Congress, there is evidently a fine distinction between that and the import of fertility, the import of family, and the import of having your son or daughter give rise to a grandson or a granddaughter, etc. While I cannot prove this thesis, I suspect it has a great deal to do with the fact that IVF was essentially left untouched to this day. And if that principle continues to hold, we may not be encountering a whole lot of opposition in the context of in vitro gametogenesis, although perhaps another quote is appropriate here. As you know, seeing the future is not perhaps for us to undertake, and it's really impossible to tell what's ahead. But judging by past precedent, Rob, there is at least some room for hope that this may perhaps not quite be the victim of unwanted attention.
Let's hope so. Are there any other questions for Dr. Adachi this morning?
Dr. Adachi, hi, it's Stephen Ralston. It's so nice to see you here.
I'm here.
I will echo Rob's sentiment that I always leave your sessions feeling like I am really ignorant about some area of medicine that I thought I might have known something about. So thank you once again.
Thank you.
I have a slightly related question to what Rob asked about the politics behind this, which is, how do we convince the public that these national organizations are not political in their makeup and in their outlook in coming to their conclusions? Because that's often a critique of these national organizations, that they are, liberal elites that are on them.
No, thank you, Steve. I would say that's a very appropriate and I think reasonable point and concern. Of course, I don't know if there's any truism in that presumption. Last I checked, your political affiliation is not on the form you fill up when you apply for membership with any of these organizations. But I can understand the sentiment, and I can understand where this notion comes from. Perhaps that's where public participation becomes so important, because that's a random process. It does not select out people by their political views, by their religious predilections, or any other position that they may hold by dint of their views or by dint of their heritage. And so if we could really convince the public that we went through an open, fair, and truly unbiased national inquiry process like they have done, as I said, in Europe and in the UK. But we have yet to rise to that level. I think that will go a long way towards putting minds at ease. And at the very least, you could cite the results of those surveys or efforts that would at least allow you to make a point. Whether or not this will carry the day, if you told me that you felt the sentiments are so strong that no matter what evidence we throw into the pool, the convictions would still be that some fudging is going on and that this is not entirely above board, I won't argue with that. I think there is a level of fundamentalism, perhaps is the word one could use, that is sometimes difficult to deal with in our country. And I don't have a cure for that at this point, although I have a lot of thoughts about it, and perhaps we can dedicate a session at one point to the whole matter of really of choice, the history thereof, where the United States stands relative to the rest of the world, why this is so. It's a very interesting and complicated issue. And so it's a little difficult to summarize, but your point is well taken. I'm not sure that in vitro gametogenesis will necessarily enjoy smooth sailing. It's entirely possible that that's not the case. All we can do is do the best we can. If it doesn't happen in the United States, the likelihood is it will definitely happen in Europe and in other parts of the world where these constraints are not applied.
Well, thank you for that. And I'm definitely going to be wary the next time I have coffee with you.
I hear you, Steve, but I hope you won't forgo coffee with me for that reason altogether. I would miss that.
Dr. Adachi, it was an honor and a privilege to be with you again and seeing you. And we here at University of Maryland look forward to the time that you can, in fact, be here in person to give grand rounds again. And we look forward to that day. So
that would be grand.
Yes, it would, in fact, be grand. Thank you for such a stimulating, thought-provoking lecture this morning. It's certainly, as Stephen said, your lectures do bring things that to most of us we had not a clue with. And I hope that stimulated many of our residents and our staff's thought processes this morning as it did to us. So thank you so much again, Dr. Adachi.
My distinct pleasure.
All right.
Thank you.
Everyone, thank you so much for attending, and we'll see you at the next meeting right after this.